welcome back to Hack Code. In this tutorial, we're diving into a common yet interesting coding question, contains duplicate problem. So this problem asks us to determine if a given integer array contains any duplicate elements. It's a fundamental question, but that tests our basic understanding of DSA. So whether you are preparing for a coding interviews or just love coding questions, mastering this problem is essential. So let's get started. So the given question is like, given an integer array, return true if any value appears at least twice in the array. So return false if array element is distant. So here we see the examples. This is true because we have this duplicate found here. This is false because it's a distinct array, and here it's true because we have this duplicate sort of duplicates here. So yeah, so let us look into solving this problem. So first we got this brute force approach. Brute force is like trying all possibilities until we find a way. So here we just iterate to the array, and then since we use two loops because we want to iterate to the array and we have to check if other element is same as this element. So we should iterate from the next but one element from this element to the length of the array. So if we find this nums of I is equal to nums of j, then return true. Because these two are equal, then we have to return true. Else and after iterating to all the elements, if we don't find any duplicates, we have to return false. So let's discuss about the time complexity for this. So the time complexity is O of n square because we are using two for loops here. It's straightforward, so n square. So space complexity is 1. Since we don't store any extra array or like that for this solving this problem, we have the space complexity is 1. So let's look into the efficient approach. So using the hash set, this approach involving iterating to the array and sorting the elements in this hash set as we go. So if we try to add an element that's already present in the set, we know that we have found a duplicate. So that's how the approach works here. So let's walk through the example. So start with an empty set that is seen. So set basically set contains elements like whatever we iterate, we just add into it. So first we add 1 to the scene set. So scene is 1. So second, so this second element is 2. So now scene is 1 2. So we add 3 to the set, then 1 2 3. So before adding the lost element like to the set, we check if it's already there. So if it is there, it is actually there, so we return true. So that's how this approach about. So let's look into the code. So as I said, we iterate to the nums, and then if num is in scene is a set, so we return true. Just straightforward. So see, else we add the number. So after iterating to all the set and we don't find any duplicate, we return false. So the time complexity is O of n because we iterate only once to the loop, that is using only one for loop. So and the space complexity is O of n because we use a set that contains that max at the worst case it will contain element of as length of array n. So it's O of n space complexity here. So let's look into solving this problem in practical. So I just have the code ready here. So now let's execute the brute force approach. So brute force is, this approach is accepted, but let's try submitting it, how it would respond to all the test cases. So here it's compiling, you can see this. Yeah, time limit exceeded because we have the complexities O of n square. But the input range for the given range, it won't be suffice. So let's try with the optimal approach. First let's run this. I just replaced the call of the function to be hash set 1, and then let's submit this solution. So yeah, that's accepted and beats 45% of the users. So that had optimized solution. So conclusion, while the brute force approach is straightforward to solve contains duplicate problem, the hash set offers a much more efficient solution in terms of the complexity. As developers, understanding these trade-offs is crucial for writing an optimal code, especially for the large data sets or performance critical applications.